All right, so in this next example, it's more of the same thing as example one, except you just have a different expression here. It says use the sum formulas to rewrite the sum as a rational function s of n, and then find the limit as n goes to infinity of s of n. Okay, so what we just did in example one, we're doing the exact same thing. We want to somehow get rid of the summation symbol, right? Evaluate what this is in terms of n, right? Such that our index is gone, our summation is gone, and then of course applying the formulas that we just learned. Okay, all right, so as you can tell, right, you can, whenever you see an n of some sort in the denominator, you can always move it out. So I'm going to do that and move it to the outside, and I'm just going to have I'm just going to FOIL this in the numerator. Okay, so over here I'm going to have I is equal to 1 to n of I squared plus 2i plus 1. Now keep in mind, right, this I is not an imaginary unit, okay, so don't get confused. It's your index right here, okay, so don't say, oh, I squared is -1. It is, but in this case, this I is being used as the index. Okay, now you can take the individual sum of this, right, using your property number 2 for summation properties. So just be careful when you apply the algebra here. Draw the parentheses, okay, from I is equal to 1 of n of I squared plus, now for this one right here, I'm going to move the 2 on the outside, right? The constant can go on the outside. 2 of I is equal to 1 to n of I, and then just plus I is equal to 1 to n of 1. Okay, so again, I applied the splitting up property for summation of this whole expression. Okay, make sure you draw this parentheses because this 1 over n cubed is being distributed to this whole thing when we simplify. Okay, now you take a look. Right now you can actually apply your formulas. And so, I don't have these formulas memorized myself. I just look it up whenever I need to do it. So for the I squared one, right, if you look at your notes, the I squared one is n times n plus 1 over 2n plus 1 over 6. All right, so let's write that in. You're going to have 1 over n cubed, n times n plus 1 times 2n plus 1 all over 6. For the I one, right, we basically just use the one that we used in example 1. So it's going to be 2 times n plus 1 over 2. Those 2's are going to cancel. I'll show in the next step. And then, of course, if you have a sum of a constant, the rule is you just take the constant and multiply by n, so it's just n. Okay, so all my summation symbols are gone. I have everything in terms of n, right? And the rest, as I like to say, just all algebra. You need to combine it into a single rational function. And if your algebra skills are strong, right, this shouldn't be super difficult. Okay, so let's finish this problem here. These 2's are going to cancel out. I would do a little foiling here. So 1 over n cubed, you're going to get n. This guy right here is n squared plus n. And let's do some foiling here, okay? So you're going to get 2n cubed plus n squared plus 2n squared plus n all over 6. This guy right here, you're going to get n squared plus n. And then if I add this n, right, I'm going to get 2n. So plus 2n. Okay, so let's combine some like terms over here in my numerator. I'm going to get 2n cubed plus 3n squared plus n over 6. And this guy, right, multiply top and bottom by 6 over 6. So I'm going to get 6n squared plus 12n over 6. Okay. All right, so you can combine like terms over here in the numerator. You're going to get 2n cubed plus 9n squared plus 13n all over 6 times 1 over n cubed. And this is the part where you can factor out your your single n. This should be an n squared, right? Plus 13. And then, of course, it's going to cancel out with this, right? Okay, so after all that work, the final answer is going to be 2n squared plus 9n plus 13. This should be a squared over here, over 6n squared. So this will be my S of n. Okay, so we'll call it my S of n. That's part, I guess we'll call it part 1. And then part 2, right, it's asking us to take the limit as n goes to infinity of S of n. Okay. All right, the limit as n goes to infinity of S of n. So really quickly, right, if you just take the limit and divide top and bottom by n squared, right, the final answer is just going to be 1/3. But let's show all the work. Okay, so equals the limit as n goes to infinity of 2n squared over n squared plus 9n over n squared plus 13 over n squared over 6n squared over n squared. All right, so this is going to go to 0, right, if n goes to infinity. A constant over a large number goes to 0. Constant over a large number squared definitely goes to 0. So you're just going to have 2 over 6, which we know is just 1/3. Okay. All right, so there's nothing really to it. It's just be careful with the algebra and applying the formulas. Make sure you are careful in inserting the parentheses. Okay, and then of course, always show your work when you're taking limits. Of course, you can find the answer really quickly. If you're asked to find the answer, like if you're enrolling Calc AB next year and you're taking a multiple choice test or whatnot, and you're not required to show work, right? For a limit like this, right, you can quickly just find the rational, horizontal asymptote, right? These degrees are the same, therefore it's 2 over 6, which is 1/3. But on a show your work kind of problem, which is your homework, basically, you definitely have to write out all the steps. All right, so just for extra practice, the last example, I'm just going to cover up. I already have all the answers there for you. See if you could try it on your own, and then maybe pause this video and then see if you get the right answer. So for part B right here, do the exact same thing. Okay, the expression is I is equal to 1 of 3 minus 2i quantity squared. It looks like I already foiled it here for you. But yeah, just pause it and see what you get for n is equal to 100, and then also for n, take the limit as n goes to infinity. Okay. All right, so hopefully you've, maybe paused it and tried it for a few, minutes on your own. So let me just kind of go through the steps right here. After you FOIL it, right, you want to split it up of summation of 9 minus summation of I plus 4 summation of n over, I is equal to 1 of n of I squared, right? This constant comes out. And then, of course, the limit of a constant is just the product of the constant times n. That's in formula number 1. For the I one, right, you just plug in n times n plus 1 over 2. And then for the I squared one, right, it's n times n plus 1 over 2n plus 1 over 6. All right, so as you can see, these terms are going to cancel out, right? 4 over 6 reduces to 2/3. 12 over 2 is 6. And then you have a single term over here, single term over here. That's no longer a fraction. And then, of course, you still have a 2/3 over here. So from this line all the way down to this line, right, all I did was algebra combining these terms. And so your final S of n should end up something like this. And were you to plug in, n of S of, 100, right? This is S of 100. You're going to get 1.293 million. And then, of course, the limit, right, if I take the limit of this, right, if I plug in a really large number, cube it, minus a very, very large number, plus a very, very large number over 3, it's going to go to a very, very large number, but it has to approach a specific number, right? And so we're just going to say does not exist, right? If you were to actually graph this, right, your function would look something like this. And as you can tell, as the limit goes, as n goes to infinity, right, this thing's going to go on forever. It doesn't approach a specific number, so that's why the limit does not exist.